Okay, let's check out this word problem using Lagrange multipliers. Again, perhaps it could have been done without it, but in this section we're going to focus on that. So we have this open box, okay, no top, no lid, and we have 300 square inches of material. This is going to be part of our constraint. That's how much material we have to make this box. Okay, we're trying to maximize the volume. So that is the function in which we seek to maximize. Now it's an open box with a square base as well, so that means both, the bottom left or bottom front and bottom side are the same. We'll call it x. So the volume of a rectangular prism, right, a box, is length times width times height, which is x squared y. This is what we have been using, a capital F, right? But then I need the constraint still. So let's hold off a second. Okay, the constraint. We have 300 square inches of material, so that's going to build a surface area function. I have 300 total, and I need the area of each of the sides, but remember there is no top. So the bottom area, right, we have x times x is x squared. Each of the sides, though, we have x times y, right, in inches squared. The units would also be inches squared. So the left and the right are xy, but also the front and the back are also xy, right? If we look at the front square, for instance, we have a length of x and a height of y. X times y is also xy. So we have 4 of those. All 4 sides are the same for xy. Okay, using Lagrange multipliers, remember this has to equal 0. So that's simple enough, just subtract the 300. Okay. So now let's build our Lagrange multiplier. So we have f equals the function that we're trying to maximize, x squared y, pretty basic one, plus lambda times g, x squared plus 4xy minus 300. All right, take each of these partials, partial f, partial x. We get 2xy plus, let's see, 2x lambda. This one, for once we have an x in here, right? So be careful of that. So we'd have 4y and then lambda, so 4y lambda, and then 0. Partial f, partial y. Y is a variable, so we just get x squared. Y is a variable, we get 0. Y is a variable, we get 4x times lambda, and then 0. And the last one's easy enough, right? Partial lambda is always just g, x squared plus 4xy minus 300. Okay. Solving for lambda. Oh, I was reading that as an x. That is definitely a lambda. Bad choice of variable here. Let me make that clear. There we go. Maybe that looks more like a lambda. All right, well, solving for lambda in this L1 and the partial with respect to x, we'd actually need to factor that out, right? We need all the lambdas on the left and everything else on the right, so I won't skip a step here. We get 2x lambda plus 4y lambda equals negative 2xy. Factor out a lambda, and then divide. All right, this lambda is quite ugly compared to the other ones we've seen. This one isn't as bad though. I can solve for lambda pretty easily here. Lambda, I won't skip all the steps. So we get 4x lambda equals negative x squared. Divide by 4x, lambda equals negative x squared over 4x. We could cancel one of them x's because, it could eliminate a possibility, but more likely it's 0. Because we can't divide by 0, right? So we'll just go ahead and simplify, negative x over 4. Now, if lambda equals negative x over 4 and lambda equals negative 2xy over 2x plus 4y, then that means that they equal each other. Right? Bit ugly here. We need to solve for x or y. I don't, at this point, really know what's going to be easier. I don't like all these fractions, though. Let's go ahead and just do cross multiplication. Right? Multiply the denominator on both sides, basically. The LCD, so we would get negative x multiplied by 2x squared plus 4y. So negative 2x squared minus 4xy equals, multiplied by 4, we get negative 8xy. All right. Again, I don't know what is quite easiest. I think since we have these xy's, let's bring those to the right. Let's add 4xy's, so we'd get negative 4xy equals negative 2x squared. Might as well get rid of these negatives. Divide both sides by negative 1. Well, now I have a clear winner. Let's solve for y. Right, that will definitely be easiest. So divide both sides by 4x. So y equals 2x squared over 4x. Cancel the 2 and the 4. Cancel an x. So y equals x over 2. Alrighty. Now take that and substitute it here. Okay, so we're using g, right? So let's use this g. X squared plus 4x multiplied by x over 2 for y minus 300. Remember, this also equals 0 as well. I failed to write that. I guess I didn't write it in these either, but otherwise that kind of didn't make sense. I was doing a little too much in my head. Anyways, so 2's cancel. So we get x squared plus 2x squared. Let's add that 300 to the other side. So 3x squared equals 300. X squared equals 100. Do the square root. We know x equals 10. Because I can't do negative 10 in this word problem, right? So I know that this length is 10, and it's in inches. So this base has a 10 by 10. So now we just need y, but y is just x over 2. So since y is x over 2, we have 10 over 2, which is 5. So the dimensions, you know, is 10 by 10 by 5 inches, where 5 is the height. Okay, these are the base.